I've been hit by lots. All right, we are going to start our lesson now. Thank you everyone for being so patient at the beginning now as we had that little transition to my mobile setup. What I want to do is, has anybody managed to get the second Maths 24 question?
So just sorry to interrupt there. I don't know if you can hear me or not, but your screen is just showing your OneNote, like the name at the top. It's not, there we go. That's fine now.
Is it showing properly now?
Yeah, it's showing now. It's showing now.
Yeah. I had to switch to my, my mobile setup, but I'm just going to restart my graphics tablet. So we're just going to wait a moment or two more. Students are still joining us, and I'd love for everyone to try and get the Maths 24 question that is still on the board. So the blue one really is the one that is left, and then we'll start the lesson for real. I've been quite lucky that I have dodged load shedding most of the time. So we're trying to get to 24 using just these four numbers. Sarah, are you on fire at the moment? Let's have a look. 4 minus 1 is 3. So 4 minus 1 is 3 times 2 plus 6. I think you've got it, because 2 plus 6 is 8. So Sarah is our new Maths 24 champion. Well done, Sarah. You are winning at life. Okay, I just want to start with essentially a little bit of admin. Ms. Anya, do you have any announcements related to admin for tonight for the students? And also, yeah, just to welcome our new students as well.
Yeah, so I'm just multitasking on my side. Okay. So hello everyone, my name is Anya, or Miss A or Miss V. I'm also a maths teacher along with Sir. Sir's the main teacher. I'm just the assistant. So my role is I basically help with everything that's happening in the chat and all the technical issues if you do not know me. If you are new, please just give me a thumbs up or so in the chat, or so I can see who's new. Announcement wise, I mentioned last week about we're going to run a holiday program on the week of the 28th. It is in your monthly fee or so. So it's not an additional payment. So if you would like to join us, you can have access to that. So I just see now that what you're writing, we are still on the Maths 24 question. So I don't know if your screen's a bit laggy or so.
Let me stop sharing for a second and then reshare, because I think with the transition across to, there's something happened maybe in Zoom. How about now? Are you seeing my writing?
Yeah, now we can write. Yeah, so I'm just going to say again, so we're going to have a holiday program run from the 28th. It's included in your monthly fee thing. You can join it, but you don't have to join it. It's especially for those after you get your reports, you're not very happy with your reports, I highly suggest you use it. And then, yeah, we're still going to have lessons next week and the week thereafter, just not on the 21st. On the 21st is public holiday. And then last but not least, please stay on towards the end of the lesson. I'm going to pop a link to the fun quiz. Every Wednesday we do a fun quiz. So that link will be in the chat. And I think that's all from me, sir.
Yeah. No, just a very warm welcome to everyone. And the topic that we are covering, and we're almost at the end of this unit, is circle geometry. And so that's the main focus for tonight. And I think it's time that we get going with that. Now, I want to start the lesson with a bit of revision, actually, of previous lessons. And when we were learning about circles, we've had to actually learn a whole bunch of facts or theorems about circles. And so I want to start by just emphasizing the reasons that we use whenever we use these facts in an argument. And we're going to do that tonight. We're going to practice questions where we not only give the answers as numbers, but we have to give reasons. Basically, I wanted to start by recapping. And so the main reasons in previous lessons, there's three main collections of facts we need to know about. The one deals with facts that deal with the center of the circle. So you'll see in all of these ones here, there is a center of the circle involved. So that's the one collection. Now you'll notice that, okay, so this one over here, there is a center, but it's not actually being used. In this one, this could actually be with this collection up here. And then these ones are essentially dealing with chords or cyclic quads. And the other main collection that we have is a collection of facts that relate to what we call cyclic quadrilaterals, or quadrilaterals where all 4 points are on the edge of the circle. And so there are some facts that we need to know about cyclic quadrilaterals. And in the last lesson, we spoke about these things called tangents. Now, if this is your first lesson, this will feel very, very quick, but we've done a whole bunch of previous lessons that have been recorded that you can look at any time. So this last collection was what we did in the last lesson, and this dealt with this thing called a tangent to a circle and its relationship between a tangent and a circle. So what are some of the reasons you're going to see me suddenly start using today? So one of the reasons, the first one is that the line from the center of a circle, if you zoom in, that the line from a center of the circle centered perpendicular to the chord, if you have that, then you know it's going to be cut in half. So that's the one reason you'll see me using. And often, Miss Anya, you said it looks a bit like a T shape. Then the other
Yes, that's correct.
Is line from center to midpoint of the chord. If you have that condition, then you know that that line will be perpendicular. Then the other one we've discussed previously is that the angle at the center is twice the angle at the circumference. So that is this one over here. Look, the arrowhead shape. This one over here is called the butterfly, or we call it the bow tie theorem or the butterfly theorem. And the shorthand we use for that fact is angles in the same segment. If this is your very first lesson, I'm going a little bit fast for you to suddenly be explaining. I'm just giving you the shorthand reason that we use, that we're going to use throughout today. So if it's your first time, just let this wash over you for now. Then the other fact we learned about was that angles in a semicircle are equal to 90. And then the other one we have is that if we have equal chords in a circle, they produce equal angles both at the center and the circumference. Then related to cyclic quadrilaterals, if you've got a cyclic quad, the opposite angles of a cyclic quad are supplementary or add up to 180. This thing in green is the shorthand reason. And the exterior angle of a cyclic quad is equal to the basically the interior opposite. The reason is just exterior angle cyclic quad. And then the last ones are just the tan radius or tan perpendicular to radius, tan chord theorem, and then tangents from a common point. Now, I do not expect you to know all of these off by heart. I just wanted to show you them at the beginning. And then today, throughout today, we are going to be using those reasons in our arguments as we go. So just give me a thumbs up if you broadly understood what I was talking about. Give me a thumbs down if you're feeling horribly confused. I just want to get a feel for the group. I'm just introducing these words for reasons that we're going to use today. It's kind of like in grade 9, you would have had reasons like angles on a straight line or something similar. I can't see too much from the chat, Miss Anya, because I'm only on one monitor now because of load shedding. So if you could just...
No, it's all good. I just had one question from Sarah because we're going to start working with reasons. Sarah just asked, ma'am, for the T one. So I know there's like tan perpendicular radius. And what's the other one? If you they just want to know how can they write in the chat. So I said they can literally write tan. It's like instead of write, because obviously you can't type the upside down T, they can literally just write PER. I know that will mean perpendicular. So not purple, not PUR, PER, and we'll know that means perpendicular.
So the other thing is you don't have to write all the reasons in the chat.
Yeah.
In the chat, I think we're just going to write numbers, but on your piece of paper, I want you to write the reasons, and then you will see me write the reasons as I do it here. So in the chat, still stay with numbers only, but I will just, today, I'm going to start writing more reasons. And the reason I waited so long into the course before I did this is if you try and do everything at once, it just gets very confusing. And so my experience is learners appreciate a bit of time to get used to everything. And then from there, they are comfortable enough to then start adding reasons after that. Sorry, guys, I'm just raising my screen a little bit so you can see me a little bit.
And I think it's also, before we start, so I also like the idea of you know, first try to see, like, for instance, I spoke about, like, can you see a T in the question? So if you can start
Yes.
identifying this, obviously you're not going to write as a reason because I saw a T. Like, you're not going to write that as a reason. You can write the legitimate reason. But once you can start identifying your bow tie or your T, or like Sir said,
Yes.
it looks like a kite surfer or the one or whatever. Once you can identify those, it just gets your thinking straight. And that's all from my side, really. You can carry on for now, sir.
In the previous lessons, and again, if you're new, we've really built this up from the very beginnings. So in the previous lessons, we spent a lot of time understanding like why there is, what the relationship is between these two angles over here. And we know that there are angles at the circumference that are equal. Now, we're going to put that into practice today, but obviously because it's recorded, you do have the option of going back. And I do encourage you, if you find today sort of tough in that way. Okay, let's just start with this question. I want everyone to work out what X, Y, and Z is. And I want you to try and write down your reasons as you do that. Now, so I have to give you more time now. So I'm going to give you 3 minutes, a whole 3 minutes to do this question. So till 18:16, because I don't want you to just write the answer. I want you to write out your chain of reasons. So say, for example, you say X is equal to something. I want to know not just the something, although you can put that something in the chat. I want to know what reason would go with that. Now, the only thing is sometimes there is more than one reason, but I'll go through those options. Okay, so you are going to give me, maybe you find X first, maybe you find Z first, maybe you find Y. I don't know, but I want a chain of reasons when you write that down. And it says PS is a diameter. So it goes through the center. Okay, over to you guys. What shapes do you notice? Like Ms. Anya was saying, what shapes do you notice that you've kind of seen before? Like, what does it mean if S, R, Q, and P are in these places? What does it mean if you have a diameter? I want you to think about that for a little bit. So I think that this 120 over here, what is it called? What's its relationship to this quadrilateral? That could be important. Okay. So I want you, when you've got your answers, to put them in the chat. And so I want to see, what are you getting for X? What are you getting for Y? What are you getting for Z? And then we'll talk about the reasons. I want you to write them down on paper, but just not put them in the chat yet. So David has Y is equal to 120. Okay. I'm not sure I agree with that, David, yet. To me, this reminds me of something we did way back, where if you have a diameter, what angle does the diameter subtend on the circumference? So subtend is our fancy word for building an angle, or like an angle is based on something and you subtend an angle somewhere. I think the angle Y is something special. Okay, yes. I think it's 90 degrees. So angle Y is going to be 90 degrees. Oh, let me rather get.
And then while Sir's writing 90, another way you can try to interpret it is if you think of O where the origin or the midpoint of the circle is, that angle is 180, correct? Because it's a straight line. Yeah. So the well, in plain English, the opposite angle in the triangle, that's how I used to remember it when I was at school. It's not a correct theory, but it has to be half of that. So the half of 180 is 90. So David, that's how you would get there. Don't worry, David. I can see those emojis in the chat. You just need to keep trying.
Keep swimming, buddy. Keep swimming. Okay. So if you look at Y, I've put the reason angles in a semicircle as the reason. Now, for Z is 120, I think that I wouldn't go with that. There's two ways you can find Z. The one is to say, is to figure out this angle over here is 60. And if you know that that is 90, then Z would have to be 30. So that's the one way of doing it. In fact, I think that might be the only way of doing it. But no, oh yeah, go ahead.
Sorry, so you could have also done exterior angle for triangle.
Oh, you're right. Yes.
So someone in the chat mentioned that. Sorry, now I'm done.
No, absolutely. That is spot on. I would have probably gone for the X first. And I would have said, look, this 120 is the exterior angle of a cyclic quad. So let's just take a moment while I try and do this. The exterior angle of a cyclic quad is going to be equal to the interior opposite. And so we would say X is 120 degrees, and the short reason would be exterior angle cyclic quad. So that would be the quickest and most efficient way to do it, would be to get like that. And then we still have to get, and I think students are probably still dealing with it. The other way you could have done it is you could have found the 60 over here and then said opposite angles in a cyclic quad are supplementary. They add up to 180. And so you could have said that once you know, sorry guys, once you know what this is 60, that has to be 120. That's another way of doing it. And then for the Z, the Z, you'd have to say, you have to do a little bit of working first. You'd have to say, look, angle, what have we got there? Okay, we don't really have a thing. You'd say angle QPO is 60 degrees. And if we're doing reasons, it's just going to be angles on a straight line. And then we could go to Z and say Z is equal to 30 degrees. And we're using the fact that the sum of the angles in a triangle add up to 180. And that's how we know Z is 30. So if we really want to do this question, there's other ways you could have done it that are equivalent, but that is the full written thing. Okay. Now, again, you may find that a little bit tricky. That's fine. I think we just need to keep practicing. Before I move on, are there any questions though? I think I should pause for a moment. What areas are there any questions from the class? Yeah.
I just want to check quickly. Sorry, I had to quickly upload a few things. Okay, so a few questions I've had so far is also, just remember guys, like I've got a few questions like, why is this 60 and why is this? So remember, there's more than one way to approach these questions. So I'll try my best to help you in the chat, and I'll also ask you to reach out to me as well, because as you saw, sometimes Sir sees things first that I don't see, and sometimes I see things a bit differently. And that's that's the art of Geo, is that it's different for everyone. So if you're really stuck, please reach out to either of us. That's why we're here.
So let's stop the next one. We are going to try and find X and Y, and I want you to put the answers for X and Y in the chat. But then I also want you to write down on your page the reason. Come Valette, yes, this is easy, the second one. But it's not. Oh, you still have to be careful. So, but I think it is easier than the last one. So let's see what you get. I want to know what X and Y is. What relationships, what shapes are important? I think there's no center of the circle here. but there is this thing called a cyclic quad, where a quadrilateral with all four sides, all four vertices on the edge of a circle. And I think that might be important. Okay, so I see some answers coming through already. X equals Y equals. Okay, what is the relationship between this one over here in pink, it's quite a dark pink, and this one over here? What is their relationship called? I think their relationship is that this is the exterior angle of a cyclic quad. And the exterior angle of a cyclic quad is equal to the interior opposite. You could have done this the other way we were doing this earlier on in the thing was you could work this out as being 75 angles on a straight line and then saying these two add to 180. But I think a lot of you will start to see that the exterior angle is equal to the interior opposite. You can just go straight to the answer over there. So Y is 105 degrees, and we just say exterior angle cyclic. Sorry for my writing, guys. It's a small screen today. Cyclic quad. And then what about X? Let's have a look. How do we get X? Oh, X is also going to be exterior angle of the cyclic quad. It's just going to be hiding on the other side. So this is also an exterior angle of a cyclic quad. It's just that it's the exterior angle on the other side. And so X would be 88 degrees, exterior angle, cyclic. Sorry for my writing, guys. Notice how I'm using the abbreviation EXT, exterior, and this for angle. Okay. And I think that was, I think people were, it takes a while for the brain to warm up, doesn't it, guys? Nicely done, Wandile. Nicely done, Nokwanda. I can see you are on the money. Well done, David, to Sarah. Let's see. Okay, let's do number 24. Find for me the values of Y and Z using the correct reasons. Now, this reminds me a little bit of an arrowhead. That's all I'm going to say. An arrowhead. There's actually two different ways you could get this answer. Yeah. So Y equals something, Z equals something, and what's the correct reason? Aha. I haven't mentioned the name of the correct reason. I see a lot of you are getting Y is 68, which is correct, but what is the correct reason? The reason is going to be angles in same. Oh, my handwriting is under severe pressure today. Let me try again. Angles in same segment. It's kind of what we call the bow tie or the butterfly. This one and this one are going to be each equal to 68. What is Z equal to? Is Z equal to 68 as well? Who thinks Z is that? Let's give some more time. I see lots of Ys, but not a lot of Zs. Ah, Sean has a different answer. It's a lot bigger than 68. Let me see if I agree with Sean. Who else has an answer for this? Okay, Sarah agrees. Okay. So a lot of people suggesting that it's 136. You're absolutely correct. Then these two are not equal. This one and this one do have a relationship. The one at the center is twice the angle at the circumference. And so the reason is just angle at center equals twice angle at circumference. That's the reason. Angle at center equals twice angle at circumference. And so we will move on from there. Okay. I've got so many things on the screen at the moment with the chat bar and the thing bar. Let me see if I can find another Okay, this is a bit of a sneaky one. I want to see how many you can get. What is x equal to, and what is the correct, or what are the reasons we have to do? $110 is just hanging out at the center. Ah, I'm going to catch some of you now. I can feel it. So, this is very sneaky. This actually, what you need to do in this question is the angles that are being compared. The angle at the center is actually this one over here, and the angle at the circumference is this one over here. You can see it if you look at these dots. It's a little bit confusing. So what we need to do is first work out what this one, the blue one, is up here. This is the shape where it's almost bending back on itself. And so the answer isn't 55. The answer is, in fact, well, now that I've given you that sneaky trick, this must add up to 360. And so this angle over here must be 250. That angle is the angle at the center. Now, what is half of 250? It's going to be 125. So what we have to first do is, I suppose we should say, if we're going to be perfect, we'd say AOC reflex. So the reflex, there's two angles around a point. There's the AOC one, and then there's the reflex. The reflex angle is equal to 250 degrees. Then we can say x is equal to 125, and the reason is angle at center equals twice angle at circumference. Sorry for the horrible writing. So that is the sneaky one, and I included that just to show you we actually get a couple of different shapes with the angle at the center. So the angle at the center one, the easiest one to follow is when we have like the simple arrowhead like that. But you also get a couple of other variations, like you get the one where it goes to here and then out to there. And the one that you just saw now was when you have a really big, like, so if you can imagine, you get that, and it's sort of the diamond shape. And then in that case, we're actually comparing this one and this one over here. So that's just something to be aware of, and that's why I included it. But it doesn't come up that often, but it's good to be aware of. Okay, I think you've done okay with the warm-up ones. I think it is time for, it's almost time for our break, but I feel like I need to squeeze in one more exam type. Let's just do one exam question, and then we'll get going. Okay, we'll have a break. So this is taken from an old exam, I think that I set once upon a time. And the first thing you see is that there's a lot more detail going on. All I want you to do is not the whole question. I want you to try and answer 2.1 and 2.2. That's it. I want you to see, can you find out the value of A2 and A1? And then for yourself, can you write the reasons? The only hint I'm going to give you is, where is A2? A2 is over here. So that is A2. Notice how the colors are, it's much easier with colors. And then A1, where is A1? A1 is up here. I want you to try and read the information that is given. A lot of circle geometry is just taking the time to read the question. And I'm going to give you until 18:35 or 4 minutes to try and answer that and write down reasons as we go. Now, you need to think what other shapes or facts that we've been dealing with lately may come into play here. What's this thing on the outside? I can't help myself. What's this thing on the outside? What's that got to do with anything? Okay, over to you guys. Ms. Anya, is there anything that I haven't been aware of or missed in the chat?
I'm just checking now. Canvas asking, isn't that C2? And Kevin's also saying it. He thinks A2 is marked wrong. Yeah, so you.
Okay.
Yeah, you marked them wrong. So you're green. You marked it C2. That's what. So you marked the coloring wrong. That's the thing.
No, thank you so much. So I'm having a moment. A2 is not down here. A2 is over there. And so A2 is up there. My apologies. Thank you to my eager-eyed class of students. So A2 is here and A1 I got correct. So that was there. Yeah. And so see if you can find out what is the relationships, what other relationships can you deal with. In the previous lesson, we spoke a lot about the relationship between this. Well, let's even look, where is ATC at 105? Like, what does that mean? Where is ATC? No, is that correct? ATC. Oh, ATC
yeah, it should be T2. Yeah, correct.
Yeah, so T2. So this over here, why do they call it ATC? Yeah, they should just call it T2. Yeah. That's going to be 105. But okay, so that might be helpful. That might be helpful in just helping me know where I'm going. Let me make that a bit smaller. So 105. And then CTU is 40. So that's over there. So how can that help me figure out these other ones? Kidibana, what reasons are you using to find, what's your reason for A2 being 40? I agree with you, but what's the reason that we use? So what is this shape? You remember from the last lesson when we did that shape? That's the relationship I think Kilibona is using. Let me make it a bit thinner. So we know CTU is 40. Yes, Kilibona, it's the tangent. Okay, let me help you on this one. The relationship between the angle between the tangent and the chord is equal to the angle in the alternate segment. So we know that this one over here, A2, is going to be 40. And the reason is just called the tan chord theorem. That's it. The angle between the tangent and the chord is equal to the angle in the alternate segment, but we just say the tan chord theorem. That's it. That's 40. Now we know at the beginning I said that this one is given to us as 140. Now what's the other thing we're still trying to find? We're trying to find out what this one is here. I want to leave that open and then we'll take a little break. Oh, there's something else hiding, guys. There's something called a cyclic quad, which is here. There's radii that are involved. What else can we... it's a little bit sneaky.
So...
Yeah.
So just a tip I want to give students as well, and especially for those that are using a tablet or phone to watch this lesson. Sometimes with these, it's difficult to view it, but what's nice if it's on a piece of paper or tablet, otherwise something you can turn around.
Yes.
It's sometimes nice to turn your circle around. So let's say, for instance, you want to have your tangent at the bottom. Then sometimes you see things differently that you didn't see before. So that's also just a tip when you do get these for homework, like on your textbook, just turn your textbook around a bit and then maybe you'll see something.
So what I want to suggest now, because I know we need to have a little break before we just keep going, is can you see that if this is 40 and that's 105, this one over here has to be 35? So that's something that's quite important. And potentially, I could also say, and again, I know I'm going fast, but this is an angle between a tangent and a chord. This is going to be 35 down here. Now, I'm not sure that helps me too much yet. What else can I look for? I'm kind of going hunting now. Angle at center is twice angle at circumference. So this, oh wait, so that is 40. We already proved that that was 40 earlier on. And now what do we have left? BC equals CT. Oh my goodness, guys, look at this. What does that mean? BC, this one over here, is equal to that one over there. So those two sides are equal. Does that mean anything? Let's have a look. For some reason, my brain is still drawing a blank. Angle at center is twice angle at circumference. I know that this one down here could be 75. So that's that one. Okay, yes. So that's 75. Now, what else do we have? Okay. I'll tell you what. Let's have a brief. Miss Anya, are you seeing anything that I'm not seeing?
I'm also checking here. I'm also hitting a lacquer blank.
So it could be that I'm missing something on the moment, but let's take it a moment to have a break. Let's have a quick brain break.
I'm gonna have to stay so long while you guys go do that. Yeah.
All right. So guys, what I want you to do is halfway through the lesson, we always have a little bit of a brain break. And we do this just let our brains kind of release from all the kind of heavy learning we're doing. So I want you all, let me stop sharing. I want you all to stand up and see if you can see what's going on here. I want you to just do this exercise with me, and then we'll go from there. There we go. In fact, let me share the screen so Ms. Anya can see what we're doing, but hopefully you guys can still see me on the screen. Give me a thumbs up if you can see me nice and clearly.
I can see you, sir.
Okay, so guys, what I want you to do is I want you to have your right hand, and I want you to put it on your nose, and then I want you to take your left hand and put it on your right ear. Okay, now I want you to take your left hand and shift it to your nose, and take the hand and go to the opposite ear. So now you've switched. Now I want you to see, can you take your right hand back to your nose, your left hand to the opposite ear? And then I want to see, can you switch back again? So, see, can you keep doing this and keep switching? If you can manage to speed up, you should find it quite hard unless you've been practicing. And we call that a brain break, because it helps our brains to just kind of release the mass for a second. And I want you to turn your cameras on if you can. I'd love to see your attempts at this. So I know that it is a bit tricky, but again, take your right hand on your nose, left hand on your ear, and then can you switch across to the opposite? I'd love to see if anybody can do that. Show us how fast you can do it on the cameras. Let's see who is a winner at this. Sarah is Rika. Oh my goodness. You seem to have really got it. Kamvaletu. Yeah. Lunguisi. You getting there? He's getting up to speed. Well done, guys. I can see all the effort you're putting in. Well done. So what I'm going to do is, Ms. Anya, I don't know. I'm not going to, if there's something that, I don't know for sure there's something wrong with this question.
I got one. No, I've got one value. I can do 2.3. So it's a cyclic quad.
2.2. I wanted the A1 part. That's the only part.
Yeah, I'm also for some reason stuck there by A1 and then by C2, but angle B I can work out, not a problem.
But for now, instead of going deep into this question, I'm just going to press pause on this. I can come
Yeah,
back to the next lesson.
I think so
I just
too.
want to check if there's anything that I've missed that's obvious. I might have just missed something, but
No, same,
for
yeah.
the moment, it's not going to be efficient use of time. But let's go and look. I have another question prepared a bit like this.
Sometimes it's good if you go look at another question as well when you get stuck in a quiz.
Okay, this does look a little bit scary. So let's look at something like, look at this question. Okay. All I want you to do in this question, we're going to take it bit by bit. As we look at this question, and typically exam questions are broken down like this. We have 3 different questions. All I want us to concentrate on is this question over here, 4.1 or B2. Now, before we start finding what B2 is, I want us to really look closely at the information. And I think in the last question, I didn't really take enough time to really speak you through what's going on. So O is the center of the circle and BC equals CD. Now, I noticed that that hasn't been marked on the actual circle. So let me take a moment to actually do that. Let me zoom in so that you can see it hugely and say to myself, look, I need to remember that BC equals CD. So BC, that's a bit big. Let's go with something a little bit. So BC is equal to CD, and because that could be useful at a later stage. Then express the following in terms of X. Now, what does it mean to express something in terms of X? It means that my answers are always going to have an X in it. So when I give you the answer B2, I'm not going to give you the answer of B2 as 30 degrees. The answer is going to have an X in it. So that's what it says. So let's find where B2 is at the moment. So B2 is this angle down here. So I'm going to try and find that in terms of X. I know that the angle at the center at the moment, the only thing I'm given in this whole question is this angle at the center, which is 2x. Now I have to think, how can I build a relationship, or how can I build a journey between this 2x and this angle over here? And I want you to see what answers do you get for that. So if you could just try your best, what shapes are in the actual drawing? Like what shapes do you see here? Some of the things I see are radii, but I also see angles at the center and angles at the circumference. And I just want to leave it open to the floor. Can you get me an answer for B2? And I'm going to give you a little bit of time to try and get that. Now, you might have to go somewhere else first in order to get there. That's my hint. Let's see what you can get here. What could this, what do radii help us with? That's what I want to kind of point you in the right direction. What are these special things over here? Maybe they can help us. Kamvaletu. Nolwazi, you're late. You are late. If we go back to the very first lesson on circle geometry, radii have, the line from the center of the circle to the edge has to be an isosceles triangle. Yes. Now, how can we help us? How can the isosceles triangle help us find what B is in terms of X?
I've got the answer if the kids are flooding in so long to double check.
So if you think about it, you know that 2x is taken up by the middle. So it's not going to be 60. Okay, let's, so this is a different type of question, guys. Instead of asking us to give an exact number, we're now working in terms of X. So let me do this. I want us to focus on 3 angles within a triangle. So I want to say that these 2 blue ones here have to be equal because of the radii. Okay. And I know that all three, the two blue dots and 2x add up to 180. And so what I'm going to find is I have 180. If I go 180 minus 2x, then I'm left with, I've basically, if I want to work out what B2 is, it's not 180 minus 2x. It's going to be 180 minus 2x, and then I'm going to have to divide it by 2. And the reason I divide it by 2 is that there are two of these angles over here. Now, what is 180 minus 2x divided by 2 equal to? I want you to write that in the chat. Anybody have an idea? What's 180 minus 2x over 2?
A tip, you'll need to factorize.
Yeah, or just divide both things by 2. That would also...
Yeah, that's also quite easier.
So what's 180 divided by 2? It's going to be 90. And what's 2x divided by 2? It's just x. So the answer for B2 is 90 minus x. Kevin, yes, you're on the right thing. 90 minus x. So this is a new type of question that we haven't done before, but we, instead of finding the answers as numbers, we're finding them in terms of x. So let's see if I use, let us try, actually, I want to get a feel for how people are feeling. If you're feeling okay with this question, give a thumbs up. If you're not feeling okay, give a thumbs down. I just want to get a feel for the class as to how much detail I should go into here.
And then, so while the kids are prompting, I'm seeing quite a few students write, for instance, like 45 and stuff. Nowhere in the question for 4.1 to 4.3 do we want actual values. We always want it in terms of x. So you should not have basically just the numbers and answer. X must be somewhere in your question. So just read your questions carefully, okay?
So basically what we're doing here is we're saying in this new question, no longer do you just want numbers, you want the answer in terms of X. Okay. I think what we're going to do is, again, we'll start, I want to build up to these questions a little bit more. Let's end with one last question where you actually get to find the values again. This isn't actually as scary as it first appears. So let's finish tonight with just finding what angle LMN is. So you're given this big drawing. So we're just going to do one. We're not going to do both. I want you to get me in this question. You're given LON is 100, which is here. And they say find the value of LMN, which in this case, it's only asking for a value again. It's not asking for a variable. LMN is this value over here. So what is that value going to be? And I want you to think of the diamond shape we had earlier in the lesson. Okay. Okay, it's not equal to 100. I've drawn the two blue bits here to show you the angle at the center and the angle at the circumference. Aha, yes, Kamvaletu, yes. Okay. So remember, we want LMN, which is this one over here, and it is in a relationship with this other blue one over here. Now, the tricky bit is we need to figure out what this big blue one is. And so this is going to be 260 degrees. And then, because this is the angle at the center, it's twice as big as the one over here. Now, what is half of 260? It's just going to be 130. Okay. And so if I was right, I haven't really been writing reasons now because we're running out of time, but all I would have done like earlier is I would have said LON reflex equals 260. And then I would have said LMN is equal to 130. And the reason is angle at center equals twice angle at circumference. So I divided it by 2. Yes. because the angle at the center must be double the size of the angle at the circumference. Now, guys, we're really getting into proper exam questions. You can see these come from past exams. So if you are still feeling a bit unsure, totally fine, okay? We need to work up to these, and these last 2 lessons in the course are going to be going towards these types of exam type questions and just building our confidence with a couple of easy ones, then a little bit of the hard ones. And I'm going to try and show you some of the different types of questions we can come across. But you have to keep going back and recognizing the shapes and playing with the different ideas. And for those who are new tonight, what I want you to do is I want you to try and look at some of the past videos where we talked about these ideas. Okay. Ms. Anya, is there anything, I think it might be time for us to send the students off to do their fun quiz. Nawazi, exactly. Don't be late again. You'll miss all the fun. Is there anything you want to make the students aware of?
No, I just think practice makes perfect. I think a few pointers to give you guys, before I give my pointers, you guys already have it better than I did, because when I was at school, when we did Euclidean geometry, I was on hockey tour for 3 weeks. So I missed this chapter and calculus completely. So at least you guys get to have first-hand experience of this as well. So just think of that whenever you struggle, just think, well, at least you weren't Miss A when she was in grade 11 and missed this. Anyway, just some tips with regard to this is try that trick, especially when you do your homework, of like turning your textbook around, see it from a different angle, try and use color, ask yourself, right, you're going to use lots of color. Ask yourself, do you see a bow tie? Do you see a kite surfer? Do you see a T? Do you know, start recognizing any shapes or so. And if you really struggle, all the lessons we do are online. So just make a point of it one evening or so to just go watch through a lesson, and don't just sit and not work through the examples. See if you get to the same answer. I think those are the only real tips from me.
So the biggest thing I would do is whenever I start these questions quite quickly because of the time pressure, you know, in terms of, you know, what we're doing. But in reality, you get 3 to 4 minutes for each of these small questions. And so it's worth taking the time to think, oh, what is in this question? What have I got? Well, I've got the center of the circle. I've got, you know, 2 radii. And so that might come in helpful later on. Oh, wait, I've got an angle at the center, and I've also got an angle at the circumference. So almost go for like a leisurely walk through the information, making little notes as you go first. And then when you're ready to write down your argument, that's when you sort of do your thinking. And I think that's something which I want to emphasize. You have a bit more time than we're currently giving you. And so take the time to get familiar with your environment. Okay, we're going to call it there for tonight's lesson. And I'm going to ask you to go to the quiz, section of tonight. And so just do the best that you can. The quiz isn't as hard as the questions we're doing right now. The quiz is checking just your basic fundamental understandings. And so, I think you will find it, you know, fairly to your liking. And I will see you next week, Monday. And then once you go off to do the quiz, you are free to then, you're finished with the lesson today. However, if there's some more questions, I will stay online to assist those students. So please feel free to hit up with the questions now. I'll do anything else.